By the time when I was learning about the statics basics in the university, I was already working with Autodesk Inventor. I knew about frame analysis, so I took one of those classic exercises of a simple supported beam and I smashed my face on the monitor after seeing the results not matching perfectly. Was math broken? Was the software wrong? Of course, it was me. So here are the reasons why FEA won't match your analytical calculations, especially on static scenarios. But before continuing, I invite you to subscribe to this channel. Okay, so as shown in here, you can see that I have been already playing around with this model, which is taken from Shigley's Mechanical Engineering Design book. This is more specifically the exercise 3.2. So I will start a new fresh assembly so we can go step by step. So I will click on new. In this case, the exercise has been done using imperial standard. So we are going to take an standard that is in inches. For the assembly, I will double click. So this happens in assembly environment. Okay, so the first thing is to have a line element. Let's say this one, for example. As you can see, it already has 20 inches, and this is a part that basically I did before starting the exercise. So I will ground it into the region. That's very important. And now that it is grounded, we need to save the thing. So I have some generic names in here. So let's save it as assembly number 2. And now what we need to do is to jump into the design tab here at the top and insert a frame. Okay, so in this case, it doesn't matter if it is a circular section tube or a box section or a beam. It really doesn't matter. So I will pick this. That's totally fine. I will apply. I will click OK to all these things. There you go. There we have our element created with frame, well, with the tool for frame in Autodesk Inventor. That's the only thing that you need to consider, because if you do the extruded tube, it is not going to work. This is a very intelligent model that you are seeing in here. It is a tube, but it has a lot of information. It has a lot of value for this exercise. Okay, so now we're going into frame analysis. It clearly needs frame things already created. We will create a new simulation. We want static analysis. Click OK. So as you can see, our model has been substituted by a line here, and it has 2 dots. Okay, so this defines the element itself. The program already recognized the element and converted into a line element. Okay, so the following thing that I will say it's obvious to add is the constraints, but I will jump first into the forces. So we already have one that comes from in default from the software that is right at the center, but I need another one. So I will click on force and I will pick a point along the element. So if we look at the exercise, we have one force at 4 inches. So I will click here 4 inches. I will click the check for accepted. And now I'm going to double click on the arrow. So I will have this dialog box. I will add 200 pounds at 4 inches. That's right. So as you can see, you can also change the angle and play around with the force, but in this case, we're going is vertical to the element in this case. Okay, so we will hit OK. This other one, whoop, this is the gravity, sorry. So this is the gravity by default. So in this case, we're going to leave it, so you will see what happens. I will add an extra force. I will click in here. I will say this is at 10 inches. I can right click and click on more options. So I go straight to this dialog box instead of accepting the thing and then right click, etc. So let's go here, 100 pounds. And now we have 3 different loads. Now let's go into the constraints. So the usual thing that the regular scenario is to go on fixed constraint. We will constrain in this one at this point because I can see from the diagram that the fixed constraint, the reaction number 1, is the closest to the 200 pounds force. That's why I did first the forces. Sometimes the thing could be flip. Okay. And now on the other side, I could apply floating pin constraint. So let's go at this pin constraint. That's okay on orientation. Perfect. I will click on down. That's it. So now let's jump into simulate this. This is simple as that. That's pretty simple. So now let's go to beam details. In here, you need to click on the beam because you could have multiple beams, you know. In this case, we have just one, and we will check the forces on Y. So we have here at the right the summary of stuff that we are getting from here, from this thing. So as you can see, for the fixed constraint, that is the one on the left, we have 259 pounds, and it is expected to be 210. And if we go to the other floating thing, it is 43. It's supposed to be 90. So what's going on, right? So here is the trick, let's say, and more than a trick, the explanation. So when we do these things on 2D, those are statically determinate elements. And Autodesk Inventor is ready for solve indeterminate scenarios instead of determinate. So we need to help the software to figure out the reactions the way that we need them. Okay, so I will delete these 2 constraints because they are, they are far from not being helpful right now. I will delete just the fixed constraint and show you something extra because we have also the option for pin constraint. That sounds like that should be the solving thing, a pin constraint and a floating constraint on the other side. We click simulate and we get this message. So this is an instability, sorry, in the air, and there are X and RC, there are rotations and other stuff like that. So that's those only having these troubles, I would say you cannot trust what you're doing in here because software is letting you know something is happening. So if we look at the 3D representation of this is kind of going aside. Sounds like, yeah, we have troubles. So the following thing that I'm going to show is because I already explored software. So it is to use a custom constraint. So let's go to the side where we are expected to have a fixed constraint, or fixed as we know it in 2D on the books. And for those ones, everything is going to be fixed except for the z-axis in displacement and also in rotation. It should be uplift known, which means that it can move in any of both directions. Okay, so I will click OK. That's one. And the opposite one, the one that is floating, this is a very interesting thing because looking at the different scenarios, I was trying to leave displacement free in some of the different components X, Y, Z, but it was not really working. It was always giving me these problems on the report. So at the end, the thing only requires to have rotation uplift known in here, and the rest can be just fixed. Okay. So as you can see, this element in here is shown in this way. Each of these ones are the different directions X, Y, Z, and in this other one, as we have uplift known on the C, it is showing like that. Okay. So now let's click simulate. Let's check the results. Okay, now we do not have errors. And then now we are going to check the beam details. So if we check, oh, sorry, I forgot to pick the beam. Now, there we are. Okay, so now we are getting closer to what is expected. So we have 211 and 91 pounds. We're still not perfectly there. So the reason for that is that on our exercise on the tree 2, we're not taking into account the weight of the element. So what we need to do in Autodesk Inventor is to suppress the gravity. With that, it's going to be more than enough. Let's take a look. I love how quickly the things are resolved in this module. It is pretty quick. Okay, now we are matching perfectly well. Let me highlight in here 210 and 90 on the other reaction. So now we are perfectly fine. And also on the moment, if you look up down here, we have the moment, the max moment, and we are matching with the 900. Okay, so all these things are just because on the 2D exercise, everything is simplified, let's say. But in real world, or you're more up to work with hyperstatics, with indeterminate scenarios where you have the structure and it becomes more complex. But understanding this kind of things, I believe, is pretty important. Have a better understanding and also judgment about constraints. As you can see, it can make a completely different thing scenario if you select the wrong type of constraints. Okay, I hope you have learned a lot. I'm pretty sure this sort of video is also going to add you more knowledge about FEA if you want to take a look to it.